Today we are going to talk about parallelograms. And this picture right here is a pretty good example of what parallelograms look like. It's kind of like a slanty rectangle is usually how they're pictured. So by definition, a parallelogram is a four-sided figure with both pairs of opposite sides parallel. And that's what they indicate in the picture. Those arrows indicate that those opposite sides are parallel. Now, besides that, parallelograms have four other properties. So we talked about opposite sides being parallel. Also, opposite sides are congruent. So this side and this side are congruent. This side and this side are congruent. Opposite angles are congruent. Notice like these two small angles are congruent. These two big angles are congruent. Now the next one is consecutive angles are supplementary. So consecutive angles means ones that are next to each other. So we could be talking about these two, a small and a big, or we can be talking about these two, again, a small and a big. So I like to say this like a small angle, oops, that says angle. A small angle plus a big angle is equal to 180. And then finally, the diagonals bisect each other. Well, we got to put some diagonals on here. So the diagonals go like this. There's one long and one short, but they bisect each other. So bisect means they cut each other in half. They cut each other in half. So these two pieces are the same size, and those two pieces are the same size. All right, so how we're going to use these properties, we're going to use them to solve for some missing angles and sides in some given parallelograms. So for this first one, remember opposite angles are congruent. So question mark is 85 degrees. Done. Super easy. These two now, in the second problem though, this is a small and a big. So we know that 74 plus x has to equal 180. Okay, we can call that x. And so if we do this, we get x is equal to 106 degrees. Now this next problem, these are congruent. They're both small angles. They are congruent. So my equation is going to look like this. The 6x minus 2 is going to be equal to 46. We're going to solve it. And we get our answer, x equals 8. So we're solving for the angle or x if x is the case. Notice it's a big and a small. So the relationship between these two is the two of them together add to 180 degrees. So this is an interesting problem because we end up with x plus 180 equals 180. And when we do this, we get x is equal to 0. Well, that's possible. Remember, when we're solving for x can be positive, 0, negative, because it's just x. It's not the angle itself. Now these opposite sides are congruent, so 6x minus 3 equals 15. 6x equals 18. X equals 3. Now these last two problems are about the diagonals. And remember, the diagonals bisect each other. So these two purple parts are congruent. So we know that negative 4x minus 2 is equal to negative 3x plus 4. Solving them, we get x equals negative 6. So again, remember, x can be negative. It doesn't mean that the whole side is. In fact, you can see when you plug them back in, that will give you positive measurements for those parts of the diagonal. Now these two yellow parts are also congruent because that's bisected as well, which means 3y minus 5 is equal to 2y plus 8. So solving these, we get y minus 5 5 equals 8. And finally, y equals 13. And finally, we've got these two x parts are congruent because that diagonal is bisected, cut in half. And I'm going to solve it now. 6 equals, 3x plus 12. Negative 6 equals 3x. Negative 2 equals x. And finally, these two are congruent. So y plus 23 is equal to negative 4y minus 2. Solving. Y equals negative 25. Y equals negative 5. There you go. That's how we can use those 5 properties of parallelograms to solve for missing segments and angles, including the diagonals.